Okay, today we're going to be working on some absolute value equations again. The first thing we're going to do is look at your SAT paper on problem number 1. So when you have a problem, the first thing to do is read the problem. And would you also underline what it is it tells you to find? What is it you're trying to find in problem number 1? So let's underline that. And so we're trying to find the x-intercept. I am guessing that you probably have forgotten how to do that. Am I right? You know how to do it or not? Okay, so we're going to write down the equation on your paper. And if it's the x-intercept, it's on the x-axis. On the x-axis, the y values are 0. The way you find x-intercept is you let y be equal to 0. So what is 1/3 times 0? 0. This part zeroes out, and this is what you solve. This is what gave some of you some difficulty solving with fractions. This is not the only way to do this, but you solve the fractions by multiplying by the denominator. You multiply by the denominator. To multiply a whole number times a fraction, you multiply the whole number times the numerator and keep the denominator. What is 20 over 5 reduced to? And there's still an x. I am solving for x. What am I going to do with the 4? The x-intercept is 5, 4. In point form, this would be how you would write the x-intercept as a point. It depends on what the multiple choice answers were on SAT, which way you would put that. Yes. This was one of the most often missed problems on the quiz on Friday. And so when you're solving an equation, just a linear equation, the first step is to distribute. Now don't write this down, because once again I'm showing you common mistakes. This is what I saw a lot. Is that number out in front that you are trying to distribute, is that number a 3? Is a 1/3 and a 3 the same? No, but I saw that a whole lot. I saw the 3 distributed. So I'm supposed to distribute what number? 1/3. To multiply a fraction times a whole number, you multiply the whole number times the numerator and keep the denominator. To multiply a whole number times a fraction, you multiply the whole number times the numerator and you keep the denominator. Now, I am distributing. Do I multiply a 1/3 times the other side? Right here is where the distributing stops. Now, I think the other thing that I saw people doing is they were trying to cancel the fraction, but that's not step 1. The first thing you do is distribute, and then you worry about canceling fractions. This stays the same in this step right here. All I've done is distribute. Now I need to reduce. What is 3 over 3 reduced to? What is 12 divided by 3 reduced to? Do I have to worry about fractions anymore? Some people got all the hard fraction stuff right, and then they made a sign mistake on this next part. Now I need to get the x's together. I need to get the whole numbers together. It is your choice. Do you want to get the x's on the left or on the right? Somebody say left or right. Which one? Okay, if you want to move the x's over here to the right, I need to subtract 1x from both sides to cancel that out. 2 subtract 1 would be 1x. If I'm going to move the x's to the right, I need to move the whole numbers to the left. So I'm going to add 3 to both sides. And what is that going to be? And so that may or may not have been the problem on your test, quiz. Everybody had a problem like this, but not everybody had this particular problem because I do not give everybody the same quiz because I know this is going to be a surprise to some of you, but some people cheat. And so we have to try to do what we can to stop that. Okay, next, would you please look at your gold-colored notes. The gold-colored notes are on absolute values. Does anybody need a copy of the gold-colored notes? Okay, first of all, let me remind you that an absolute value is talking about a distance. The distance can never be negative. And when we solve an absolute value, there's always going to be 2 answers because I might have the distance to the left of 0 or I might have the distance to the right of 0. And so that's why there are 2 answers because we don't care whether we're going to the left or right. We just care about what the distance is. We have our steps to solving an equation. The first step is to isolate the absolute value. The second step is to make 2 equations. These 2 equations that we're going to make, we're going to call them case 1 and case 2, just so I don't get confused about what you're doing. Okay, and we solved problem 1, and we solved problem 2, and now we're on problem number 3 today. So, what we need to do is isolate this absolute value. Outside of the absolute value, nothing added, subtracted, multiplied, or divided to the outside of the absolute value. That's what isolate means. We need to get rid of the adders and subtractors first. We need to get rid of the 8 first. What are we going to do to get rid of the 8? Now, if this was a parentheses instead of an absolute value, we would distribute the 3. But remember from Friday, you never, 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 never distribute into an absolute value. I need to get rid of the 3, and I cannot distribute the 3. The 3 is multiplied by the absolute value. The opposite of multiply is divide. I'm going to divide to get rid of that absolute value. This is isolated. It's on the left-hand side of the equation by itself without anything added or subtracted to it. It is isolated. And so now we are going to make a case 1 and a case 2. And so this is going to be x minus 4 equals 6. Exactly the same problem without the absolute value. Do we have exactly the same thing without the absolute value signs? That is case 1. Case 2, we're going to put parentheses where we had the absolute value, and we're going to put a negative sign out in front, because if this represented a negative number, we would have to multiply it by another negative to make a negative times a negative equals a positive. Okay, solve both equations. Add 4 to both sides over here to cancel out the 4. There's one answer. Over here, I have to distribute the negative first, and then solve for x. The opposite of plus 4 is subtract 4. I am solving for x. I need to divide by negative 1 to cancel out that negative sign. There is my second answer. You have a case 1 and a case 2. You have 2 equations. You solve 2 equations, and then the next thing in our steps is to check the 2 answers that we got. How do you check an answer? Now, you may not have room to fit this on your paper, so you can look up here. You go back to the very original equation before you did anything to it, and you substitute in your answers. What was our first answer? 10 minus 4 minus 8 equals 10. You simplify inside the absolute value. The absolute value does nothing to a positive number, and so does that check out? Check mark. What was our second answer? Negative 2 minus 4 minus 8 equals 10. You simplify inside the absolute value. The absolute value does not make that 2 into a positive 2. After you simplify, it makes the negative 6 into a positive 6. Does that check out? We have 2 answers. Both of them check out. In our next example, this is the absolute value. This is the part we're going to isolate. You isolate it by getting rid of everything that's added, subtracted, multiplied, or divided on the outside of the absolute value. You do the adders and subtractors first, the 3. What am I going to do to get rid of the 3? The opposite of add is subtract. This 4 is divided into the absolute value. What's the opposite of divide? If I multiply by a 4 on this side, I have to multiply by a 4 on that side to keep everything equal. The reason I multiply by the 4s is to cancel it out. Now, this is isolated. After you isolate the absolute value, then you have a case 1 and a case 2. X minus 5 equals 28 is case 1. The exact same problem without the absolute value. Case 2, where you had the absolute value bars, you put parentheses and you put a negative sign out in front. Solve both of these equations. The opposite of minus 5 is, and so the first thing you do to solve case 2 is distribute the negative. Negative x plus 5 equals 28. We're going to subtract 5 from both sides. I am going to divide by negative 1 to get rid of the negative sign. I have my two answers. And what do I need to do next? Check. I'm going to tell you a shortcut about checking, though. You ready? What was this after I isolated the absolute value? I had x minus 5 equals, what was it, 28? If, in this step, you have to isolate. If the isolated absolute value is equal to a positive constant, your two answers, both of them, will always check out. If your absolute value is equal to a positive constant, your two answers will always check out. Is that 28 positive? Is it a constant? What does constant mean? That was one of our vocabulary words on the first notes. What does constant mean? Constant means it's going to always be 28. It's not going to change, and the reason it's not going to change is it doesn't have a variable. Is that 28 or 28x? Just 28. If you have an absolute value equal to a number without a variable, a positive number without a variable, those two answers, assuming you hadn't made a sign mistake along the way, those two answers will always check out. You can put them in there and check them to see if I'm right. Okay, so this problem right here. We need to isolate the absolute value. I need the absolute value by itself, nothing added, subtracted, multiplied, or divided to the outside of the absolute value. Get rid of the adders and subtractors first. I need to get rid of the 8. How? And then I solve case 1 and case 2. Case 1 is the exact same problem without the absolute values. Case 2 is the absolute value bars changed to parentheses with a negative sign out in front. To solve this, I'm going to subtract the 1 from both sides. I'm going to distribute, and now I will add the 1 to both sides. Divide both sides here by a negative 1. X equals positive 1. I have my two answers. Right? Raise your hand if you need a minute for this. Are you just stretching or you have a question? Okay. So let's check. If you don't have room to fit in the check on your paper, just look up here. What was my first answer? And so when I add that together, what does the absolute value do to a negative 2? Is that true? It's not true. Is it true? That's not true. That means x equals -3 was not a true answer. Well, what was it then? Did anybody see me make any adding or subtracting mistakes when I was solving it? Assuming that you did not make any mistakes solving it, if you check it out and put it in the original equation and it doesn't check out, it is called an extraneous answer. Does that kind of look like the word extra? It's an extra answer that isn't really supposed to be there. It's not really an answer. It's extra. It's an extraneous answer. Well, what about our other answer? What was our other answer? Positive or negative? +8 equals 6. The absolute value of +2 is still +2. Does that one check out? 2 + 8 is equal to 6? It doesn't check out either. This is also an extraneous answer. Well, if both of the answers are extraneous, they're both extra answers that aren't really the right answer. What's the answer? Here's the answer. We had some extraneous answers, some numbers that weren't the right answer. Did we have any that were the right answer? Nope, no solution. And I could have told you that much earlier in this problem. What was the first step that we did? Yeah, so x plus 1 is equal to -2. Got that far? That was our first step. What does it say back over here on the first page? The absolute value can never equal a negative number. The absolute value can never equal a negative number. Now, you do have to do your isolate first. But after you have done your isolate, if that's equal to a negative number, this is going to be the answer. You can work it all out like I did, but when you check it, it will not work out because the absolute value can never equal a negative number. On your gold homework paper, would you please look at problem number 5 with me? On your gold homework paper, what is your first step going to be? And what's that going to be equal to? Is this isolated? Is there it now? Isolated means on the outside of the absolute value, there's nothing added, subtracted, multiplied, or divided on the outside of the absolute value. Is it isolated? An absolute value can never equal what? So what does that mean the answer is? Now, you must isolate it first. You cannot just look at problem number 6 and say equals -50, no solution. Because what's the first step on problem number 6? So on problem number 6, how are you going to isolate? This is multiplied by the absolute value. The opposite of multiply is divide. And when you isolate, is there going to be a solution? Yes, there will be 2 solutions You're going to set up your case 1, and you're going to set up your case 2, and then you're going to solve it. So, next on your homework paper, would you look at problem number 1? This is the problems that I'm doing are on worksheet 1-3. Step number 1 is isolate the absolute value. How? And if I multiply by a 4 on this side, what do I have to do on that side? The reason you multiply by 4 is to cancel that out. Then what? Case 1 and case 2. And then you're going to solve out your case 1 and your case 2 and get 2 answers. And just, let me tell you, these are both going to come out to be fraction answers. You will have some fraction answers on this worksheet. Now, here is our calendar for last week and this week. What's going to be happening on Friday? A test. This paper right here, worksheet 1-3, when is it going to be due? On Wednesday. When is your ISN going to be due? Friday. I don't know what that did.